Hi, we're going to take a look at central Florida Peninsula for today. SPC currently has a slight risk across pretty much the central one-third of the Florida Peninsula and then marginal out a little bit past that, encompassing probably about two-thirds of the total of the Florida Peninsula for today. So we're going to take a look, get a quick setup here synoptically. Looks like we got a very strong shortwave extending down through this northeast Gulf Coast region. Good cold air advection, strong advection in there at 500 millibars. So we're going to get a lot of upper level dynamics. And currently, well, as of 12Z, the surface chart indicated a major low pressure system sitting off of Hatteras, cold front extended back through the southeast of Georgia coast into northeast Gulf of Mexico. And so that's our low level system. So we got a lot of dynamics in place, and we're going to take a look at GR2 and see just exactly what's going on. So I'm going to back it up. We backed it up here about an hour to 15Z. Current time is 16:12. So we're going to get about an hour to roll out this cell and take a look at it as it moves over to Tavares, which is northwest of Orlando, west-northwest of Orlando, about 30 miles or so. National Weather Service picked up on this pretty quickly, put the storm box, severe storm box on it. So I'm going to right click over the storm box. And that was a left click, sorry. I got a new laptop and the buttons are still eluding me. There we go. We're going to set storm motion over the warning, and that is 270 at 45. So moving along at a pretty good clip. That alone, that storm motion is probably almost enough to want to issue a severe warning on this storm as it is. So let me right click on the cell here on the leading edge again, see if I get that right. And we'll put storm track. And this is going to project out 1 hour using that storm motion 270 at 45. So it's going to put it over the coast in about an hour. So we're going to take a look at this cell and watch it as it moves across and see if we catch it over Orlando Sanford Airport there, the county airport. And the first thing I want to do here, we'll zoom up just a notch or two, GR2, and we'll take a cross section through there. There's my cross section tool right there. I'm going to plant, okay, looking at the cell, we've got good inflow notch here. Maybe a couple of them. So it looks like it's pulling in here and here. So we're going to lay down a cross section through here and see if we can see what that inflow notch looks like in the vertical. And we'll split the difference there, put it about right there. And what I'm looking for is see if we got a weak echo region or bounded weak echo region, and it looks like we hit gold right away. So if you see this kind of shelf being supported here, it actually looks like it's got two sections there. Get a little better view. And you can see in the horizontal, I can spin this down, tip it down, and we can see how I landed my cross section. And we can actually move that around too. You can slide it either way using the position bar, or we can swing it. So we'll swing it to there and see how that looks. Get that maxed out inflow notch there. So what's going on in the inflow notch? The updraft is pulling air in off the surface. So we're looking down on, this is the inflow notch, that kind of wedge shape or V-shaped notch in the right rear quad of the storm. And once that air pulls in and it encounters this intense downdraft all right through there, it's got to go somewhere. So it goes up. So we start feeding our updraft. The more unstable that air is, it's pulling in as well. And it's pulling it from the southeast at this time. So what's going on is then that updraft is holding this mass aloft. So that's a lot of potential there for some strong dynamics going on with this storm. So good thing they warned on this early and just kind of mousing over. We got about, that's probably large hail right there. And down here in the lower right-hand corner in the information panel there, we can see my readout. Got about 57 dBZs. Usually 56 is a cutoff for large hail. And that's not real high. You know, it's cool season still. And we got a lot of shear and not a lot of cape at this time, especially at this time of day. So we get a lot of shear. We get kind of what we call mini supercells, low top convection, but you know they don't have the vertical extent, but they've got all the punch that a supercell might have as well. And we can also use the volumetric tool here, the volumetric mode. We're going to do a 3D volume section. So I'll start about at just south of Tavares and pull my box out. So that's what's going to be included. All that's going to be included in the 3D velocity 3D volume section rather. Let me get my alpha table up here. I think I've got it set on 56. Right there, up here you can see the readout. And I'm at 56, so that's large hail. So there's not a lot there. Just you can see that kind of blob being suspended, and it's up around 10,000 feet. So depending on what the wet bulb zero is and freezing level, will determine whether or not we get any hail out of this thing. All right, so there's about 50 dBZs. And once again, in the horizontal, you can see where the inflow notch is pulling in right there. It's got to go somewhere. It's got to go up. Can't go down. And here's our 3D version of that. So it looked like a weak ecoregion on the cross section. Looks like it might be bounded weak ecoregion. So we got a little bit of a cavernous effect here. So you're kind of showing it's kind of splitting the downdraft. The updraft is becoming more intense. And you kind of have this extra descending downdraft kind of looping over to what we call bounding the weak ecoregion. So right off the bat, we got severe signatures. There it is. That's a better, there we go. I got it filtered up a little bit higher, right at 50 dBz. We can see it. There's a good, you look kind of for a cane kind of shape to it there. So updraft right up in here, main downdraft, and going to be a right rear flank downdraft eventually if it keeps developing. All right, so that's a good spot to stop here for a second and take a look at what National Weather Service is on it. They've got their storm box plotted out on this cell. Looking at other stuff here, we've got our storm motion set. You got to have your storm motion vector set for storm relative velocity to work well and be accurate, representative of what's going on. So we've got a 45 knotter in there for our storm motion. And so right now, it does look like there's probably a good argument for a mesocyclone holding down control. We're up around 7,900 feet. We're pretty far from the radar, but what we can do is we can kind of take a quick measurement here. I'm going to find my maximum inbound velocity, so it looks like 36 knots. I'm going to place my marker there, and then mouse over, holding down control. I'm mousing over my max outbound, so it looks like 33 is probably about it. It looks like in there. Where'd it go? Right there. All right, so if you look at the DV line, about 4 rows down, 69 knots. That's a significant mesocyclone circulation. Diameter needs to be within 5 nautical miles of the endpoints, or the endpoints need to be no more than 5 nautical miles apart, and they are. They're at 3.99. That's the diameter in the same row, fourth row you can see there. Azimuthal shear 4.8, not real high, but that's because of the spread. You got a little bit of gate-to-gate shear in there as well, but it's pretty puny though. 12, what was that? 12 knots and 18. So we got about 30 knots of gate to gate. You need an upwards of 70 to start talking tornadic vortex signature, or TVS, for tornado. So I'll bump it up one. Looks pretty good. The values I came up with, 50 knots is considered at least a weak meso. So anything above that's going to be strengthening. So we've got 69. So that's probably approaching a moderate meso at that range. And if you have 10,000 feet of vertical extent, you manually verified a meso. So moving on up in the world, let's see, we're up to about 16,000, not quite 10,000 feet, but we'll take another look here. Place my marker. See what we can get for max outbounds. About the same, 12, 13 knots, over 50 knots. So we got about 10,000 feet of vertical extent to this meso. I would say that's all the more reason to have that warning box out. About 80 to 90% of mesos that are manually verified produce severe weather, either severe winds, severe convective winds, large hail, or tornadoes, or some combination of the three. All right, so that's a good start there. National Weather Service nailed it. Let's move on here to the next couple of frames.